Greetings. I've been working at this 4.5D game for a bit. Last time I got some cool stuff rendering. This time I'm going to hack apart everything I've written and try and structure it a little bit better. But right now I'm just kind of chilling. Let's have a look at the Trello board. There's a bunch of stuff that kind of needs to be done. And right now I'm doing break test code apart into organized classes / structures. Okie dokie. I should advertise this stream somewhere. Maybe I should advertise this stream thing somehow. I guess. I'm not a big marketing genius. Okay, let's have a quick peek at what we saw last time. Our little voxel world. We can fly around. It's pretty basic. There's an outer wall on the cube and some of the blocks are missing. And we've got left, right, strafe. Can fly with W and S or other keys if you change the keys around. And something else. Oh yeah, holding down shift makes you go very fast. What a lot of fun. And that's great. I mean, it's not much, but it's a start. Okay, so this is mostly due to this test module, a lot of which is just rendering stuff. Some movement code. Ideally I should push that into a sort of Lua script, so it's scriptified. A lot of rendering stuff needs to be separated out into its own rendering, and to be honest, part of this is geometry generation and then part of it is rendering stuff, so that is definitely not a clear structure of its own. It's definitely a bunch of different mishmash of things thrown together, which is fine because that's all it was going to be, just a bunch of rubbish test code. The actual room that you're in is just a three-dimensional array of zeros and ones as integers. It's pretty bare bones. Right, so rather than like hacking into the test module, I'm going to make a new module. So the modules are like the different states that the game could be in. For example, module for the title screen, module for the menu. It's a pretty standard way of structuring a little game. Right, I'm going to call this one game. Okay, a CPP file and a header file, because the 1990s were amazing. Cool, so I got a brand new module. Pragma once. Always got to start off with Pragma once. Now let's copy out. We definitely need to include module because we're going to inherit from that. Here's a... I'm a glutton for copy pasting stuff. Cool. So we've got a game and we've got update and render functions. So far so easy. Let's make the CPP file, modules, game. So we kind of have a blank slate here. Do you put override? I don't remember. Cool. Let's also add it to the make file. This is a little make file I wrote myself. I always thought make was very hard to understand, and then I read the manual and realized it was pretty genius. It's still got a lot of very dated ideas to do with special symbols implying special meanings. But in general, I thought it was very good. Mouse capture modes, I'll set to don't capture now. Okay, there we go. So I have a new module. It's not quite as exciting as the test module, but it is indeed a module. Make sure, I always get confused. Don't make sure, but let's say that. Push games. So let's try out this new module that does literally nothing. So this should be uneventful. Yeah, okay. We've got a black screen. That's fine. Okay. Now, if this is structured sanely, there's a lot of different ways. A lot like solving a puzzle, there's different ways to approach. Marcos, hi. So the different ways to approach class design or data design or whatnot. But like a puzzle, often it's good to think about it from both ends and try and meet in the middle. If you have a puzzle, often you can see what the last few moves are, and you can work out what the first few moves are. Is your game stateful? Sure. I actually don't know exactly what this whole stateful, stateless conversation that's been going on today is about. Stateful means... Stateless is if it's just, you just look at it and think about it like a riddle or something. Is that right? Stateful is where you have to apply changes, but then you get the paper puzzles where all the state changes are incremental. Like you're not really... The sort of Nikolai style puzzles, you're not really changing the state, you're just indicating a truth that already existed or whatever. I sound very disdainful about Nikolai puzzles. They're alright. Some of them are really good. Some of them are really just a lot of arithmetic. Okay. What I was going to do is split some of this stuff up. So... looking at the Trello board, which I hid, boy. Physics, some sort of rendering thing. The game module with ECS and lower capabilities. Yeah, I don't know if the ECS should be in the game or in the world. I'm actually tempted to put it in the world. Okay. So, to what I was saying earlier, one way you can approach design is you can think about what contents you would need to make a class work. For example, what variables or what member variables might make sense. I might have a world, like the whole level is a world, or it could be called a level. I like world. World with different rooms and objects. Makes sense to me. Some sort of script to tie it all together. Maybe a physics engine. think I keep calling it a rendering core. I don't know what I call it, a rendering engine. Something like that. So, a world with a bunch of stuff, a script that controls that stuff, physics engine for applying the physics and interactions, rendering engine, and probably other stuff, audio, music, which is also audio. Both of those often are, they don't need to be individual classes, like, because you're going to have one set of audio running, unless you really want to play a bunch of different sounds in a bunch of different contexts at the same time. Okay, so just something pretty simple like that. Is there anything I've forgotten? I have a list of things here that I'm looking at. Probably some other stuff. I imagine there'll be other things. Another obvious one is time is always good. Let's put some time in. In fact, you know what? Let's make that a fully fledged member variable because it's just a double. It's already good. Okay, so I want something like a world, some sort of scripting thing, a physics thing, and a rendering thing. If I get all of those done, I'll have a thing that can do stuff. Unfortunately, all of them are pretty big tasks individually. But that's okay, because we can just half-ass everything and have it kind of terrible. I already got the world spec'd out, but this is not ever actually compiled. This is just a header file I used to jot down some notes. So what I might do is move that header file to, it was called world, now I want to call it world concept. I don't want to delete it just yet. I'm going to make a new world. So I want to reload that. That's gone because it's now been moved to the side as world concept. So this is this thing I made earlier, a few streams ago, with a rough outline of kind of how this might work. Some of it makes sense, some of it kind of doesn't. It has a bunch of gaps because it was more just a sort of mental model rather than an actual piece of code that I want to compile, but now I do want to compile it. So I have a room which is just a piece of garbage. My world's going to have rooms in it. So let's start really simple. World. Whoa. And it just has a room. There we go. I put this enum of axes in because it's really nice. And I'm going to need it at some point. At some point soon. I might actually put the other one in as well. This reference frame. Okie dokie. That's good. Let's touch the source file for the world. I might move these. I might move these to their own file. I do intend to tidy up a lot of the mess I'm making here. I know I'm just spamming out random header files and source code files full of just notes and stuff, but the idea is you it's like a jigsaw puzzle. You pour out all the pieces, then you flip them all around, then you find the corners and the edges. You know, you gotta sort of put a bunch of ideas down and see what, wait for it to coalesce magically. Right, I made this CPP file because I did a initialize function for the world, for the room. Let's do one for the world. And in the world, I'm just going to call init on the room. No, not just. Okay, there we go. So all I'm doing, it's been years since you coded C++. I do it every day as a day job, and I have done for 15-ish years. Which is why I can do it without looking stuff up all the time, only some of the time. And if I get onto scripting stuff today, you'll see some bonkers stuff, because I'm going to do a whole bunch of weird template stuff that will look like nonsense. Because I've done something similar before and I want to just re-implement it with some tweaks. It'll be very nice. Okay, so we have a world. Oh, I should add that to the make file. So we're going to build the room, we're going to build the world as well. Okay, build. What did I change about that? How is that different? Oh, yes, it's very different. Okay, that built. Just for fun, let's run it, even though all it is an empty module. Okay. Cool. So we have a very boring world, which just has the one room, which just has some quasi-random nonsense in it. But that's fine. Okay, so the first part of this is done. I'll just take a pointer to the world, because I don't really want to complicate it with a bunch of ownership stuff. It's going to take a pointer. There we go. And now it won't work because I don't have this anymore. So I'm not really sure if this should be passed into the game. Should the game act upon a world? Or should the game have a world which it acts upon? Who knows? But they're two pretty similar things, so let's just say it gets a world it acts upon. There we go. And mixing stack pointers with shared pointers is probably a bad idea in general. So already thinking that maybe this needs rewritten. But let's just press onwards for now. Okay. So we have the room covered, but now it's in a world, so it could be a bunch of rooms and a bunch of objects and a bunch of different things. Subtle change, but it's probably helpful. Some of this stuff is rendering, some of it is geometry generation, some of it is game logic. So what I want to do is break this out into a rendering class. In fact, I'm going to make a folder called render, and I'm going to make a, should be called world render world. What did I call it before? It doesn't really matter. I can rename it anytime I want. I called it rendering engine because engine means basically nothing. So whatever, let's just call it rendering engine. I can call it an engine if I want. Oh, I guess that means I'm making engine code. I shouldn't be making engine code, I should be making a game. Okay, so now we have a rendering engine. Whoa, it's here. There it is, Pragma once. Rendering engine. Okay. It probably will need to render at some point as like a bare minimum. I could be crafty and feed the rendering engine into the game and then substitute out and have a debug rendering engine to do some debug stuff. That would probably be pretty nice. But I'm not going to. For now, I'm just gonna make it a class. It's going to take a world, and then it's going to be able to render that world from a specific camera position, I guess. So that by itself is lacking a lot of features that we'll need, but that's okay. You can't be paralyzed by the fear that what you're doing is wrong, because the truth is you can change anything at any point. For example, this whole thing is a rewrite of some other code I wrote before, because that other code taught me a lot, and now I'm using that knowledge to rebuild it. And the test program, I think, is only about 4,000 lines of code, so it's not a big deal. Okay, let's add that to the build. Let's add it up here. These can actually be in any order, I just like to kind of group them logically. Right, let's split off some of this stuff into a rendering engine. So I really need, I'm going to just straight copy it over, but what it should do, it should be split up into some rendering code, geometry generation, meshes and texture caches. It needs a few things, to be honest. It's probably going to be the most complicated bit of the code, especially considering how complex the rendering is in this game sort of thing. One thing I'm going to do here is do a private implementation. I'm going to get rid of that because the OpenGL stuff, I just kind of like to put a logical break between the OpenGL stuff and the rest of the code, because you get a lot of variables very quick with OpenGL, a lot of types, all of these things added in. It just ends up getting everywhere, so I like to put it in one place. Okay, where do we have the world here? There we go. And we're also going to have all of this stuff, because that was used before. There we go. Oh, but it doesn't know what that is. That's cool. We can include my little OpenGL header. Cool, now we get to the render function. Well, we already have a render function. Slap that in. The one thing it won't have is the camera position, so what that's going to have to take is a camera. It's going to take a camera. It will need more than that. I'm saying it'll need a camera, like, yeah, it will need much more than a camera. But for now, it will at least need a camera. Okay, so here's our rendering engine. I don't like to do M- if it's already in the D private pointer, so let's replace all that's probably going to break something, but it's yeah. So we don't have a room anymore. We've got room world.room. And that's fine, blah blah blah. So this all needs to go into a geometry generation thing. The rooms need to be marked dirty once they've had textures or voxels changed around, and then we need to generate new geometry. It's going to have a set of all static meshes inside the room. It needs to rebuild that. Because that doesn't have that. There we go. This should take that matrix that I call camera. Vertex is also specified in the test thing. Let's shove that in the rendering engine. Yep. It's still sad because this is not, it's a pointer. In fact, a pointer to a class that is not included. So let's actually include it. Okay, it's getting a bit happier. All the world's dots should be world arrows. Replace all of my code editing with search and replace. Yes, and that is why that is a good idea. And there we go. SF image is not being declared. Well, it's a lucky day, now it has. Vars, right. Viewport. It probably does need to know the viewport. No. It doesn't need to know the viewport? Probably. I'm trying to think about the more bizarre rendering things that are going to happen. You have a bad connection. See you later. Okay. Bye. Sorry to hear that. It's probably birds flying through the internet waves. Yeah, no, I know that what I just said is nonsense. Okay, so since the camera is getting pulled out, my aspect ratio is not needed. Let's just pull out the viewport. For now, it probably does need it. And that is about good. Okay, I think that compiled. I don't like these uniforms. Getting the same uniforms every frame. That's silly. Do I have a uniform type? I do. I think it's literally just a, yeah, it's a GLN. Because I can never remember. Initialize it to 0, I don't know why. It says build program. Okay, so I want to do use program, do program, and then let's find these uniform positions straight away. I'll leave the program on because it's going to be used anyway. And then that's cool. Now we can just set the uniforms, which probably needs to be a uniform buffer because it's going to have a whole bunch of matrices and other rubbish in it. Once again, for now, I'm just doing anything to get things into a state that makes some sense. So that's cool. Unfortunately, I need to put at least a little bit of stuff in here, which probably again could be pushed into the rendering engine and should be, but I'm not gonna because, well, because I'm not. So I'm just gonna set the viewport, clear it, clear depth, and work out some sort of camera. And then this rendering engine can now be a rendering engine. I'm going to include that rendering engine. Then I'm going to do rendering, render with that camera. There we go. Yeah, I didn't really like that very much. Okay, I see what that is. That is to do with this. I've made a Ford declared private structure. I made a unique pointer to it, but I need to actually make a destructor because it can't. The default destructor here can't deallocate a Ford declared structure. It needs it to be real, but the only place it is real is in the source file. So let's just set that up, but we also don't actually care about what it does. It'll just do its unique pointer thing, and that'll be that. Okay, what have we got now? How far are we? How close are we to? Okay, I appear to be. Oh, that's not quite right because I set the wrong capture mode. So there we go. Well, we don't have any logic for moving around anymore, but we can still see the room. So this is splitting up a little bit. The physics engine is going to be a while. So the rendering engine is there. You can't really call it much of a rendering engine. It needs to have a whole bunch of features and it needs to be divided up into things that make sense. But nonetheless, it is a start. So now I guess it's time to think about scripting, which I've been thinking about today and done some poking around with. I tend to use Lua for scripting because Lua is very nice and pretty quick. But for now, because that is something that works, and I've added a lot of stuff, it's probably a good point to just commit this and say, oh, what am I going to say? Create slightly more structured game module. It's all iterative. This is more structured than the rubbish testing, but again, it is just the testing, but splayed apart. But given time, this will become more structured. Okay, so this, how long will it be going? 40 minutes. Time to dive into some scripting. So I'm going to use Lua. I like Lua. I'm going to make a file. So I'm going to make a full Lua scripting harness thing. You can download tons of them, but a lot of them are pretty heavyweight. Some of them are pretty good, but I just want one that's nice and simple to use. It probably won't be very simple to code, but that's fine. I'm cool with that. So do I just call it like script or do I call it Lua? I mean, it is Lua, so I guess I just call it Lua. So I'm gonna call a file Lua types, which I think is also the name of a Lua interoperability library. No, maybe not. No, it's not. Or if it is, I can't find it. Okay, so I'm going to make a Lua types. And then I'm going to make a Lua script header. And that's probably going to have a source file as well. The types is just going to be some template stuff. So that's the basic layout. These are going to be cool scripts that will give me the power of doing stuff in a Lua file, which technically you have anyway, because that's how Lua works. On my other monitor, hidden away, I've got all the answers, because I've done a similar thing in a previous project in a slightly different way, but I'm just gonna have a little peek. Right, time to copy it exactly. I think I have 5.2 installed. Okay. Oh, I'm gonna put namespace because I didn't put namespace last time. Script. There's gonna be loads of template nonsense. Should I put in a namespace? I'm going to put in namespace script internal because I think this stuff is actually going to be not very relevant. Whoa, it's time for me to sneeze. Okay, the sneezing is complete, so I will continue coding. That's how it works here. We never stop. I wish I could stop, but I cannot. Okay, so I want to do a thing to push values from C++ to Lua, and a thing to get values from Lua to see. Push and get doesn't seem right. Should we push and pull? Puller? Getter? Setter and getter I don't like, they're too close. Visually the words look and sound very similar. Pusher and getter? Yeah, that's fine. It's a bit meh. Okay, so I'm going to use classes for this because I could probably do it with functions for pushing, because when you push a type you're going to pass in your Lua state, which you always have with the Lua script, and the type, for example int, so template deduction can be absolutely fine in this case. But I'm going to do it with a class anyway, because then you can get partial specialization. For example, if you want to push in a vector of some other type, then you can do that a lot easier if you define everything within classes. So I'm going to go through a couple types here. So we're going to put a push function that'll take a Lua state, L, and a boolean, and I'm going to do Lua push boolean. I'm wholesale copying bits of this from a previous project. Okay, so I'm going to change that for int push integer. Okay, cool. I also want double push number. String push string sister. Okay, so now I can push some stuff. There's more things I will probably want to push. One other thing is vec3. So vec3, I guess in Lua I would want that to be an XYZ table, and I think I did write something like this with a different thing, but vec2. That should be easy to adapt. So I want to also push vec3s to Lua because that's useful. Also, I need to include string and I need to include GLM. So it knows what vec3 is. GLM is just a library for doing things that you do in GLSL. The state with a less L and times GLM vec3. I call him T, I'm going to call it V. So it's going to be a table with 3 records and 0 array records. Push number. Set field L on the table, which is now 2 indexes deep, and we'll call that one X. Also Y, and maybe Z as well. Okay, and then the table just sitting there is now a table with the X, Y, and Z values. I say Z because the United States has permeated all world culture. Okay, that's real cool. There's some other stuff I could add there, but I can now just use that to push a few different types to Lua with template. So why I do templates? It's because I'm going to make this do a bunch of stuff with type deduction from standard function, everyone's favorite slow to compile thing. I'm going to build standard functions out of lambdas. Basically, it's going to get a bit weird if you're not. Well, lambdas are nothing new, but I'm going to use some C++17 stuff for sure because I did last time. Okay, getter. This one you are a lot better off doing classes because you don't have return type. Well, that's not true. You can just specify it. So let's start with Boolean static bool get the state L and index return Lua to Boolean L index. So that's just gonna do that. There we go. Int double string. So if it's an int to integer x. Why is that x? I can never remember. Oh no, I just make it an integer. If it doesn't work, whatever. If it doesn't work, it's just broken, so don't worry about it. To number standard string. I like standard string. It's terrible. Nah, it's awesome. Nah, it's terrible. To string. And that will. Also need to set return types on these. I'm a genius. It's a standard string return type, so that will. ToString returns a C style char pointer, which will get put into a standard string. And I also want to get my vec3s out of Lua, which is going to be actually a lot more helpful than putting them in, but you've got to give and take. So vec3 get the state L. Why do I do that with a capital L? I think that's copied from the Lua documentation. So we're going to just set Lua abs index out of index, because you can index things with negative from the top of the stack or from the bottom of the stack. And we want it from the bottom, which is the abs index. Okay, and then we want to get field, exactly the opposite of set field. Index is where our table is. We want to get the X field, and then whatever that spits out, we're going to turn that into a number. Now we're going to do the same for Y and Z. Okay, now we have some stuff, but the Lua stack is now also full of nonsense. So let's pop those three numbers now that we've because Lua 2 number doesn't like pop it off the stack or anything, it just lingers there. So we generate 3 more, we're going to pop 3 more. The table is already there, and none of these getter functions actually pop the stuff that they do anything with. Why does that say that's not found? That's right there. Did I do it wrong? Yeah, of course I did it wrong. I still know what Lua state it's in. Okay, So we can now use some templates to push and get some stuff to or from the stack. The main reason for this is that these functions all have different names, but I want to access these via types, not by names, because types can be deduced at compile time, which is what is going to happen. Okay, Lewis script, primer once, includes Lua 5.2 Lua dot. Is that right? Yeah. We call it script. I'm going to call it Lewis script because the file is called Lewis script. Okay. I'm going to need a constructor and a destructor. It's going to have its own Lewis state. And I want to give it a function to call. So what do I want to do? Do I want to call something Lua? I want to bind like a function name to some sort of function, and I also want to call with a function with some sort of name. So I might say like, oh, bind, I'm not going to type in poop, that's usually what I type in. I don't know, set gravity to some function that takes like a of x3, and then that calls through to you know, physics engine. Gravity is v or whatever, something like that. So I want to do that. So then when you're in Lua, you can just do set gravity to, you know, whatever, 0. Go down, what is it? 10, 0. You do something like that in Lua, and that'll use that binding to push it into that lambda in C++, which we'll call that code with that variable. So that's what I want to do with bind. Call is the other way around. I always want to say, hey, call update with this time. And then Lua, I want to have a function that's going to say that update. It's going to take time. And it's going to say, hey, here's the time. Or whatever. So call functions in Lua and bind variables in Lua to functions in C++. I'm going to do call first, because then I can at least get something back from Lua. So template, it's going to have some args. How many is it going to have? I don't know, but they're going to be constrefs. This is also template, so I'm going to specify it right there. This is a little bit cerebral, so I'm going to go a little bit slower. I try to be animated because life should be at least not garbage. But if I just sort of grind to a halt, I was going to do one with return value. I'll leave return values for now. So we're going to call. What are we going to do when we call something? We're going to call Lua get global we're going to get that global thing. Hopefully it's a function. Now I want to call let me just actually include the file I just wrote. This is why all that stuff I wrote before is going to be useful. I want to call that script internal pusher. I want to push all the args into Lua. These args are const refs, so I might need to use standard decay. Okay, so we don't know how many there are, but we can just say we can use what's it called? What is it called? I don't know what this. Well, I don't know what I'm about to do. I know what I'm about to do. I don't know what it's called. What's it called? It's like a Haskell type thing. I have no idea. What this is. Okay, so I'm going to just type it in. But you can put it in brackets. Put an operator, which I'm going to use the comma operator for, which executes its operands in sequence. And you put dot dot dot. And you could also put another thing if you want to have it like a default. Like that. What's that called? Template. Actually, I can't search for like dot 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 thing. I don't know what. Template. Yeah. It's a C++17 template feature. Folding expression? Is it template folding expression? Fold expression. Yeah. So it's a fold expression. Here we go. We've got reduces a parameter pack over a binary operator. So you give the parameter pack, which in C++ various templates is any expression that includes the type or the variable name, and that's considered for each parameter in turn. And then you give an operator and then 3 dots, and it's going to be in brackets, just like that. So that will push all of these args onto the stack. Then I'm going to call Lua pcall into mlua size of dot 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 args will tell me how many arguments there are, how many results are there, 0, error handler, null power. Yeah, that's right. Okay. I haven't even started on the CPP file, but that's going to be real easy because it's just a constructor and destructor, and Load new state, I think you just call it like that. I'm a little rusty on this stuff. I have documentation and things up at the side. Let me see. Nobody's chatting with me. That's because nobody's watching. Well, that's fine. No, you need to give it stuff, but if you use Lua L with a capital L, that's the helper library, which gives you the default things. Then you can do Lua L open libs, and that'll give you all the things, and then you can sandbox it so that you can't run operating system stuff, and you can't run other stuff, and you can't make everything terrible. And in here we just close that out. That's all good. Okay. That was really comparatively simple. This is a fundamental part of it, so I'm going to put it right at the top. Lua script. It didn't like. Okay, it wants an integer, so it's 0, I guess. Cool. So can I now make a scripty script? Maybe. Let's give it a shot. So we got Lua script, and we're going to include Lua script. Okay. So an update function. Let's call script. Call update, and we're going to give it vars dt. No, we're going to add that onto the time. We're going to give it time and delta time. There we go. So it can't push a float type, so this is a float. That's fine. All we need to do is go back to here. We can do it with a double. Then we can do it with a float. And now it compiles. Similarly, we kind of want to get a double. We want to also get a float. And we'll just get static cast it to a float. There we go. These are not yet tested and used, but they're probably fine. Okay, so that Lua script is completely useless because it can't actually load anything. There's a function in Lua called require, which will, it's like it includes or modules in Python or whatever. But it's a massive security issue because even if you do sandbox it, which I haven't, that sandboxing is not adhered to by require. So I'm going to write my own require function. And this is going to be real funky later on, because once I write a bind function, I'm going to bind the require. But for now, it's just going to be let's give some context for why it's called required rather than like include or whatever. It's going to replace Lua's built-in require function in exactly the same manner, but it's going to adhere to the sandbox because I said so. Now. Can't remember how you do this. No, so let's look up somewhere where I've done it before. Load file name, let's see, string. Then Lua pcall. No inputs, no outputs, no error function. That needs fixed. Does lure pcall return the number of things that it pushed onto its stack? No. No, you just have to figure out. So, okay, now a while back I had init functions in the modules. Now I'm going to use one. This is where it's getting good. Okay, game builder. No. It's called test builder. I'm getting ahead of myself. So there's a data directory, isn't there? Oops, helps if I tell the right thing. Okay, so we're going to touch data test builder. Now we have a script. So it was going to call an update function with a time and a delta time. Okay, it's just going to say it's time. It's a very simple Lua script that, yeah, give me a Lua script highlighter. This thing at the top, so this is no highlighter definition found. Cool. I'll download the highlighter. I will not download the highlighter because it does not seem to. No, yeah, that didn't work. Okay, whatever. That's not an option. You're just gonna have to live with it. I'll figure that out at some point. Okay. Why is that sad? Everything to update the version of this. Too many arguments. It is a variadic template function. How could it possibly have too many arguments? Too few I could see, but too many, that doesn't make sense, dude. Okay, so the game is updating. And it appears the script is running because it's saying it and then the number of seconds since the game module has been running. That's pretty nice in my estimation. And that'll keep ticking up. Okay, so we wrote a Lua scripty thing that does something. But it's not very useful because it just calls one function and at some point it's going to get sandboxed. So all the really aggressive parts of Lua will get taken away. It really won't be able to do anything useful unless we get that bind working as well. So now it gets even more strange. Oh, I put it. Should I have bind and call in that order? Yeah, I guess. So bind, this is also going to be, what is this going to be? I'm going to take a generic function. Okay, so we've got a function. This is some callable thing, some invocable, but it could be a lambda, it could be a C function pointer, it could be, I don't know, standard bind, I guess. Does that count as an invocable? Maybe. But what we're going to use is another thing, not a fold expression. You go away, fold expressions. template detection. What's it thing? C++17 thing. Not detection, deduction. Template type deduction? Deduction guide? Deduction guide, that's it. I'm going to use a deduction guide. So what a deduction guide is special commands, lines of code you can put in that show the compiler how to deduce the template parameters for a template. So here's what I want it to be. I want to have the return type and the arguments that you call to, and I want to bind the same old function that I'm binding function name. I want a standard function which takes the return and the args, and that's exactly what I want to bind in. Standard function is not included, so that is not a valid function. Okay, there we go. So that's cool. How do we get it to do? We use a deduction guide, and the syntax is super simple. Standard function, and we just want to initialize it with whatever we throw in, which is something you can initialize into a standard function, and the deduction guides will tell you exactly, tell it how to work it out. So this will call through to this, but that exposes all the types, and now we can really do some stuff. So if you've done a bunch of C++ Lua stuff before, what you generally do, you have a function that looks like this. In my thing takes a Lua state L, and you have to return a number of returns, and you can do a bunch of Lua commands here. And then there's a function Lua push C closure, which takes a Lua state and this function pointer, which is just my thing in this case, and a number of up values which are bound into the closure. So I want to use templates to make a function like this, which calls the standard function that I have after pulling out the arguments from Lua, then handles and deploys the return back and returns the number of parameters, which is the return values, which is going to be 0 or 1. K. That's a lot, but it's actually not too bad. So I'm going to have to use that namespace that I used before, script internal, because what I'm going to do is make the callback function, which I just deleted, so let's... okay, well I'm going to do the callback function. So this function is going to do all of that. But one of the glorious things is you can use templates here. Oops, args. So these templates are the ones we have just already deduced. So now we can make a callback specifically for this case. Now you might find that different binds have the same function signature, in which case you actually only have a specific callback. So just to get on the right page, There we go. That's the function type that we're going to execute. Oh, I'm repeatedly glancing to what I have done earlier because this stuff gets like galaxy brain pretty quick. For a very specific reason, which is that it's going to dump everything on the stack. So when you're in Lua, you call a function whatever with some parameters. Those parameters go into a stack. So if it's calling to a C closure, all of those values are on a stack, and those type templates I got earlier, they take an index into that stack. So you need to get, first thing is maybe whatever, a float, second thing is a string, third thing is a boolean, but we need to map entries in this variadic args into indexes here, which is not super easy. There's really bad ways of doing it. So you can do, there's one index, then you can do like one of those fold expressions from before where you call a bunch of things. So what is it? It's going to be the getter, get, whatever. And you call it with a++, and because it's doing it with the comma operator, that is actually well sequenced. This thing, this used to be called what? Sequence point? Comma operator? That term doesn't mean anything anymore. But I think that would probably work. But that's like a runtime thing. Now, the compiler would probably be smart enough to say, oh, well, A is going to be 1 and then 2 and then 3 and then whatever. I would hope. But what we actually want to do is do some compile time stuff, and I'm getting very tired. It's pretty late, so I don't know if I'll get onto that today. So this might have to be continued tomorrow, but basically we want to run this function. Oh, that's a good point. That's just the function type. We don't have the actual function, so we want to actually store the function somewhere. Like a standard function could have payload with it. You can't just use the type. Well, it definitely has payload because it's the pointer to what you're calling. So whilst we know what type of function it is, we need an actual pointer. That's where these up values come in, which was in some example code that I typed in and then deleted. So let me just go down here. We're going to bind We've got this function. We need to make it into a pointer type, which means we need somewhere to store it. So what would be better than just a straight up vector of unique pointers to I'm going to put script internal. Function container. No, I don't have function container. Now I think what would probably be good is you can use standard any for this. I just want a thing that holds a thing. it's going to have some random type. It's going to be a function with some return value and some argument types. So it's going to be some type we can't know in advance. But we will definitely know in the callback function, because we're going to call back into the exact right function, knowing these things. So the function that we're going to use, we know what it is. We can use standard any, but it actually has a bunch of checks to make sure you stay type safe. I don't really need it to be type safe because it's constrained by compile time logic. In that, wherever you're looking, whatever function we get here, this is handled by these things at compile time. If it compiles, it's gonna, it's done by the compiler. I'm not gonna make a typo or anything. I probably am, but you know, it's all good. So let's just make a function container. My shift key doesn't work. Okay, so... No, don't stop. Okay, here's a function container. That's really like the base. So what we want to do, we now have function type. And now, at this point, we don't actually care about the individual little arguments and return types and stuff. It's some function with some arguments and return types, but we just want the whole thing. And we want to make it into a function container. But this is really, that's just like the base. Is it base class? Is that what they call it? Yeah, there we go. Okay, so that's going to be one of them. Okay, so I'm going to delete the word function from this. It's doing my head in. Stop it. It's generic anyway, it doesn't need to contain a function. I can put whatever I want there. It's going to contain functions. No, it's just going to contain a type. I've got salty. Just contains a type. Here's a type, it's coming in. It's a cool value. You don't actually need this underscore, but maybe there's an easier way. I might be overthinking this. I probably am. Okay, cool. It really doesn't like anything I just wrote. Const type value. I see what's making this out. Okay, so here's a container from a container base. This container will have a type, and it will put it right there. And then when it dies, that type will die. And the base will virtually call that. So now we can have a big list of unique pointers to them. Okay, that was a few hoops to jump through, but we're still going. So we probably want to make one of these containers. Script internal container of type that function. I'm going to populate it with the actual function that's going straight in there. I know I just typed new. I'm going to copy this because it's good. Yeah, I'm not typing out the whole function type every time. Okay, so we got this. This is the type of it. I would probably do that from remove reference and const stuff from there, but it's the same. Okay, so we can make a container of that. Also, put it somewhere. Oh, you know what would be nice? It would be nice to put it actually in the thing. Is it in-place black or push back? Who knows? Anyway, right. So those up values, you can put some baggage with your callback, and this is exactly the baggage we want to put in. Light user data is a Lua type that's a pointer back to your own stuff, but it's light means it doesn't try and garbage collect or anything. So we want to put that pointer to the container alongside our callback, and it will pop out right here. So here's something I've had a problem with already. See this? See this? Is this going to work? What does it want? Oh, so it's the pointer to the function, which is callback, script internal, callback, with return and args, and number of up values, just one. And then we are going to set that into a global variable. There we go. Okay, so that figures out what type of function callback we're dealing with, makes a container containing that function, sticks that onto a list of callbacks. The whole point of that list is that so when this exits, this vector will clear. They're all unique pointers. All these container bases will clear. That destructor will call through to all of these, killing all the values and freeing up this because of the unique pointer, which undoes this new here. So we don't leak memory, hopefully. Oh, it's a bit of a brain drain, but it's good fun. Then it also puts that container straight onto the stack and wraps it up with a C closure to that callback function, and then sets that into a global Lua variable. So you can now call it from Lua. Right. So we've got Lua to use data. Up value index 1. So that's now our pointer to our container. but that's a void pointer, not very useful. So we need to, let's reinterpret, cast that back to a container, which is actually containing the function type. And it's a pointer to said type. So we get a pointer back. Okay. So now we have a function, we have a bunch of args, and we have a return type. The args are on the Lua stack right now, hopefully. So we need to call all these getters for all the stacks, which means we need the indices. This is the really galaxy brain bit. I had to look at Stack Overflow a bunch to find out exactly how to do this at compile time, and it was complicated. So what happens was I didn't do it. I just copied it. Well, not copied. Someone kindly explained how to do this, and I eventually understood their wisdom. So let's just check how much of this compiles. I'm pretty tired. I'm not going to get through the galaxy brain stuff at this level of tiredness. So I'm going to say time for bed. The call did work. A lot of this stuff is reasonable. It lacks comments. Does it lack comments? It's all pretty apparent what it's doing, I guess. So the intent here is, after it's sandbox, is to call bind require to that. So that will override Lua require, so we can use the same sort of syntax that is standard to Lua, but I'll run my own require function that will stay within the sandbox, I think, and just do stuff that it's supposed to. So for next time, return 0? No, this should return, should pull the value that's in the container, and it should call it with the args that it needs to get out of the Lua stack using the indexes that it needs to infer from compile time wizardry, and then it should get the return type, which, if it's void, is going to be nothing. So if it's void, I think it disappears from the template list. Whoa, somebody's grumbling. I need a midnight snack. It's past, just a lot past midnight. Yeah, so this is, let's put a to do. Actually call the callback. Okay, so what I'm going to do is look at what I've done in terms of work. A whole bunch. Let's commit that. I don't want to lose my work. What if there's a lightning and it comes out my computer and blows everything up. That would be terrible. So what I'm going to do is commit it all. Semi-implemented Lua script hook. Bang! It's all committed. So next time I'm going to actually call the callback, and that's going to be a little more bonkers than this. Wait until we get to the entity component system stuff. That's going to be even worse. Way worse. Alright. It's super late, so I'm going to sign out. Goodbye.